All right, so we have the trigonometry word problems keywords worksheet. Here's what I'm going to do. I'm going to teach you the words to look for in word problems. So if you look, there's 3 sections of words. There's the vertical side, there's a horizontal side, there's a diagonal. I'm going to tell you what words to look for to label any of those sides. So we're going to start with the vertical side. You'll see there's like 6 bullet points. You're going to fill them in. The first one is if the word problem mentions anything about height. So the first blank is height. If it says anything about height, that is the vertical side of the triangle. Anything about height. The height of a building, the height of a person, the height of a mountain. It wouldn't say height. What word is a synonym with height?
Elevation. Whoa.
I mean, no. Starts with an A. Altitude. Okay, so if it said altitude, anything like that, it's going to be that vertical side. Also, if it says anything about a pole, it's going to be vertical because poles are vertical. If it says a wall, walls are vertical. So you got third blank is a wall. We're going through these quickly. Show you a picture. We move on. So you got a wall. You've got a tree. Trees are vertical. So that's your fourth blank. This one you do need to write out the whole thing because you'll find it on a lot of word problems. The top of a slide, the top of a building, the top of your head, the top of a lamp post, the top of something. So the top of, and then I would give in those examples. The top of a slide, the top of a building. Because whenever you're told the top of something, it's actually telling you like the height of it. Okay? And then last would be the length of a box. The length of a box, or even a field. Hint, hint. You're going to have a soccer field, like on your homework. Okay, so if it mentions length. So that's all the vertical keywords. If you see those words, you can automatically label the vertical side of your right triangle. We're going to talk about the horizontal side. It's got less keywords, but for the most part, it's usually the ground. So the horizontal portion of the right triangle will usually be the ground. It probably won't even mention the ground, but unless something's in the sky, it's always on the ground, right? Slides are on the ground, buildings are on the ground, people are on the ground, hopefully. Another would be the distance. You do need to write this exactly. You see it. The distance from a building, a pole, a base. So the distance from a building, a pole, a base. The distance from a building, a pole, a base. Because you always measure distance as the shortest distance to an object. So if I wanted to measure from me to the door, you would actually measure from my feet to the foot of the door. You wouldn't measure like from my eyes to the foot of the door. You'd measure horizontally. Okay, so that will always be the horizontal side. I put a star next to this one because most students forget about this side. Anytime you see distance from an object, it's going to be the base. It's always going to be the horizontal. All right, a shadow on the ground. Because where do we see shadows? We see them on the ground. So even now, especially in the front of the room, there's not as many shadows on the back of the room. But if you look down, you'll see a shadow. It's on the ground. You don't see them in the air. You see them on the ground. Most students accidentally put them as a hypotenuse, but you don't visually see a shadow. You see them on the ground. That's it. And then the last would be the width of a box. Again, this could also be the width of a field. So that's the vertical, that's the horizontal. Now all that's left is the hypotenuse. So the hypotenuse will always, which is what it's called right here, the hypotenuse will always be something leaning or unstable. So go ahead and write that in as the first. Something leaning or unstable. So something leaning or unstable. And I will show you the most common ones. This is one of the most common. So we all visually see the triangle, right? Here's what makes this a right triangle. Anytime you see a vertical line, which you can kind of see, anytime you have a vertical line intersect with a horizontal line, they make a right angle together. So the ground and the wall make a right angle. The wall and the ceiling make a right angle. The ground and the leg of your desk makes a right angle. So what is the hypotenuse in this picture? What would we call it? A ramp. This is the second blank, a ramp. So anytime you see a ramp, the purpose of a ramp is to go from one level to another. So it's going to be a diagonal like that. This is the most common, and it is a ladder. It'll especially say a leaning ladder, but most of the time it's just going to say a ladder. Ladders always lean. The only times that they don't are, like if you want to climb up a slide, those stairs aren't.
A tree stand.
Okay, that one too. But otherwise, they're usually leaning. Usually, they're called A-frame ladders, and you walk up them like a diagonal. And then we've got a rope or a wire hanging from a pole. So a rope or a wire hanging from a pole. And I'll actually show you one visually. Before I got married and before I was a teacher, I actually lived in upstate New York, and I was a high ropes instructor. This is a high ropes course. There were like two jobs that you could do. You could either be at the pole where you'd climb up. Look, there's a ladder down here. It is leading. You'd either be here, which is what this guy's doing, or you'd be at the swing, which is how you send people off. This is actually me going to the swing. But anyways, poles have these wires coming out of them. I know some of these are harder to see. But it's to keep them stable, and it's to keep them straight up, especially when there's wind. So anytime you see any type of wire, they'll even say specifically it's called a guy wire. It's always going to be your hypotenuse. Okay. And then a diagonal of a box or a field. Or even the diagonal of a TV. Did you know that your TVs were measured by their diagonal? So when it says 60-inch TV, it's from one edge to the other diagonal, 6 inches. I do want you to write in one more that is not on this list, but you're going to write it in, and it's stairs. So you're going to write in the word stairs. So if it said the length of the stairs, that would be your hypotenuse. Okay? The last thing, if you notice on this paper, is a compass. And hopefully you know never eat soggy waffles or whatever. But if it says north or south, it's going to be your vertical. And then east or west is going to be your horizontal. Okay? And the reason that this deals with right triangles is where north and south and east and west meet. They are perpendicular. So all of these form right angles. So where north and south and east and west meet, they're going to make a right angle. So we're going to use this. You're going to set it right next to you. Do not put it away. So the whole point of this is that you actually look at it and use it. And we're going to go through the word problems on the stapled notes you picked up. Okay? So I will show you the 100% correct way to draw this picture. And then I will show you what my students have been doing, which is also fine. I'll explain. So, this is the first example. Zoe swims 14 kilometers west and then 9 kilometers south. How far is she from her starting point? So, she starts swimming, and then what direction does she go?
West.
She goes 14 kilometers west, which is to the
left.
To the left. To the left. So, go ahead. She swims 14 kilometers west, and then she swims south, which is down.
Where you're going?
Yes.
Okay.
Remember that where west and south meet, it is going to make a right angle. So that is how it pertains to us. How far is she from her starting point? So we're asking for a distance. So Remember that we are only dealing with right triangles. You have learned 2 strategies, and one of them will work and one of them won't. You've learned about Pythagorean theorem, and you've learned about trig ratios. Here we have 2 sides, and we are finding another side because it says how far, and far is a distance. So we're finding another length. Are we going to use a trig ratio or the Pythagorean theorem? Pythagorean theorem. So a squared plus b squared equals c squared. We don't know the hypotenuse, but we do know 9 squared and 14 squared. Just type the whole number in. Like, just type all of 9 squared and 14 squared in your calculator together. What do we get? 277. Take the square root. We're going to round to the 10th. If it doesn't mention it, just do the 10th. And then 16.6 kilometers. Good. So this is the correct way to draw it, like if we're trying to be 100% accurate. But what a lot of my students are doing is using that keywords worksheet that look like this and just trying to find words in the problem to match one of the sides. So since it said west, some people were putting 14 kilometers down here, and they were putting 9 kilometers here, because on the notes, it looked like this. It said north, south, east, west. I'm fine with it. This is the 100% accurate way because we went left and then down. But you're actually going to get the same answer because these are both the legs. As long as you do it correctly and you label them correctly, you'll get the same exact answer. That makes sense? So if you want to be in the habit of just drawing the triangle like that and then filling in the sides, I find that completely acceptable. Okay? Before we move on to the next question, I'm just going to remind you about angle of elevation and angle of depression. You have a picture of them. I want you to take a highlighter. We're just going to highlight this one thing. I'm sorry. We're going to highlight. The angle of depression and the angle of elevation will always have a horizontal line. So go ahead and highlight the horizontal line. And then write that both always have a horizontal ray. So highlight the horizontal line and say both always have a horizontal ray. And then I would highlight that as well. I don't know how to highlight it. Okay, so you've highlighted the horizontal line and say that both always have a horizontal ray. And here is why, I'll show you in a second why that matters. But the angle of elevation starts at a horizontal line and then opens upward. You're looking up at an object. The angle of depression starts from a horizontal line and opens downward. Okay, depression, we get that. But what I want you more so to know, I want you to draw this. You don't have to draw a lighthouse if you just want to draw like the triangle here. Let's go ahead and draw your triangle.
Wait, where at?
I don't care. Right next to the, I don't care. Wherever. So draw a triangle. Draw that dotted line at the top. And then, yes, draw the arrow and then draw X. We're going to talk about it. So you've drawn a right triangle. You've drawn a dotted line. X, all that jazz. So this is what it would look like in pictures. If it mentions angle of depression, here's what I need you to know about the angle of depression. The most common mistake is that people think that this is the angle of depression. But remember, the angle of depression always has to have one kind of ray, and it always has to be a horizontal ray. Are either of these rays that form this angle that I've highlighted in red, are either of these rays horizontal? No, you got a vertical one, you got a diagonal one. That's not an angle of depression. The angle of depression opens downward, and sometimes, all the time, it will be outside of a triangle unless the triangle is like inverted and flips upside down. But for the purpose of what we're doing, it's going to be outside the triangle. So, and then the last thing you need to know is that the angle of depression and the angle of elevation, which is this one, there's your horizontal line, and it opens upward. Like if this guy were turned around, he'd be looking up at the lighthouse. This guy up here is looking down at the person. Here's what you need to know about them. They have a relationship with each other. What do we call one line that touches two lines? A transversal. This is a transversal. Transversals make relationships. What relationship do these two angles have? I've highlighted. They are alternate interiors. So what I need you to write down is that the angle of depression and the angle of elevation are alternate interior. So the angle of depression and angle of elevation are alternate interior. Why does that matter, Mrs. Marshall? Even more importantly, what do we know about the measures of alternate interior angles? They're congruent. So, and congruent. So they are alternate interior and they are congruent. So whatever the angle of elevation is, the angle of depression is. And whatever the angle of depression is, the angle of elevation is. So pick a number, any number between 1 and 180. 67. If this angle, the angle of depression was 67 degrees, that means the angle of elevation is also 67 degrees. Okay? So we're going to see that in the next two examples. How to draw an angle of depression and the fact that they're going to be congruent to each other. Okay, so in our second example, like I told you, I do not mind if you just draw the right triangle like beforehand and then start labeling things onto it. You are measuring the height of a lamppost. You stand 40 inches from the base of the lamppost. You measure the angle of elevation from the ground to the top of the lamppost to be 70. Find the height of the lamppost, h to the nearest inch. So, let's try to label not necessarily numbers, but what these sides represent. So, what do we think the vertical side represents in this?
The lamppost.
The lamppost. Good. And even more specific, lamppost is correct. Even more specific, the height of the lamppost. Okay, the height of the lamppost. All right, and then it says you stand 40 inches from the base of the lamppost. So if, like Reagan said, if this is the lamppost, where is the base of the lamppost?
The far right, the bottom.
The bottom, that'd be left, right? Yeah.
Yeah.
The bottom left, you stand 40 inches from the base of the lamppost. So you are standing 40 inches from the base of the lamppost. Remember that if you look at the keywords worksheet, I want you to take a gander for a second. I'm going to get up in your space for a second. It says distance from, it's the second bullet point. Remember the one you starred? Distance from an object is always going to be the horizontal line. So standing 40 inches from the base of the lamppost is going to be this bottom line. So 40 inches from the base of the lamppost. You measure the angle of elevation from the ground to the top of the lamppost to be 70. So angle of elevation has a horizontal line and opens upward. So horizontal line opens upward. It's going to be this angle down here. And for every picture that we draw like this, the angle of elevation is going to be this bottom right one. Okay? Find the height h of the lamppost to the nearest inch. So, are we going to use the Pythagorean theorem, or we're going to use trig ratios? Trig ratios. Anytime you have an angle, or you're finding an angle, it's a trig ratio. So we want to find the height of the lamppost, which we've already labeled over here. We could call it x if we wanted, or you could call it whatever you want, h for height, I don't care. We're going to label the sides from the angle that we were given. So from 70 degrees, what kind of side is the height over here? Opposite. And what kind of side is 40 inches? Adjacent. So which trig ratio are we going to use? Tangent. From 70 equals the opposite, we can call it x, and then over the adjacent 40. Do I need to flip it? No. Multiply by 40. We are rounding to the nearest inch. Yep. It was like 109.8, so it's going to round up to 110 inches. Do I have any questions on this example?
Wait,
Yes, sir.
I got a calculator, but
Do you have a different type of, you have a Texas Instrument?
no.
All right, so the next page, the top of the slide is 12 feet from the ground and has an angle of depression of 53 degrees. What is the length of the slide? So again, you can kind of draw your right triangle. I just can't draw today. Good enough. So let's start talking about, what we got. We got a slide. That's all we know. What do all slides sit on? The ground. So we know we got a ground. The ground is always going to be horizontal. It says the top of the slide is 12 feet from the ground. So which of these sides is it going to represent? The height. It's going to represent the height, which would be the left. So you are all correct. This is 12 feet from the ground, which is really high, if we're being honest. I think the ceiling's probably 12 feet. And has an angle of depression of 53 degrees. What is the subject of this sentence? Has what as an angle of depression? Yeah, but I'm asking what has an angle of depression?
The person's
The slide, the top of the slide. So that was a little bit of English. This is a compound sentence. The first part is that the top of the slide is 12 feet, but the top of the slide also has an angle of depression. So this is the top of the slide. Remember that angle of depression has to have a horizontal line. This angle is not the angle of depression. The angle of depression always has a horizontal line and then angles downward. If you think that it is silly that we have an invisible horizontal line, if you've ever seen a surveyor, the guys with the orange on the side of the road, and the little tripod things they're looking through, that is exactly how you measure a pitch or an angle downward. It just is. Okay? So this is our angle of depression. It's 53 degrees. It is outside of our triangle, so it looks like it's not helpful. But what information do I know about the angle of depression and the angle of elevation? They're alternate interior, which means that they are congruent, which means I can label this angle as well as 53 degrees. Okay? What is the length of the slide? So we've already talked about the height of the slide is 12. This bottom portion is the ground. This hypotenuse is going to be the slide. And it only makes sense because slides just aren't on the ground, right? If the top of the slide is up here, okay, it slides downward. So, are we going to use the Pythagorean theorem or a trig ratio? Trig ratio. We're going to do it from the angle they gave it, from 53 degrees down here. What kind of side is 12? And then x is hypotenuse. So which trig ratio are we going to use? Sine from 53 equals the opposite, which is 12, over the hypotenuse. You can call it x, you can call it h. It doesn't really matter. We just know it's missing. Do I need to flip this one? I do.
Oh, wait, this is the one you said that's going to be hard to do.
So once I flip it, I can multiply times 12. Okay. What do we get? 15 feet, yeah. Which is actually a long slide.
What's the white one? That dirt is tall. Wherever it is. The big
What are you
white
talking to
one.
me?
Yeah.
The slide over there?
Yeah, the big
I have
white
no
one.
idea. I've never been over there
It's
on the
tall.
playground. I think they frown upon adults who don't have children who belong to the playground at the playground. You know what I mean?
People whack their head all the time.
All right, we're doing one more. Come on. One more, and then you're on your own. We can even listen to music while we work. Come on. So, the angle of elevation of a ladder leaning against a wall is 70. So, we know we're dealing with a right triangle. We already know the angle of elevation right off the bat. What is the angle of elevation? 70. So, where am I going to put that? Yeah, bottom right. So if you're drawing it the same way every time, this is our right angle. This is the angle of elevation. Opens upwards, got a horizontal line. So let's talk about what each of these sides represent then. We've got the word ladder. Which of these is a ladder?
The far left.
The hypotenuse is the ladder. We also, so ladder leaning. We also have the word wall. Which of these would represent the wall? Yeah, the left, yep. And then, we can even read this. The base of the ladder is 1.4 meters from the base of the wall. So where is the base of the ladder located? The bottom. And the base of the wall is the bottom. And we know that they are 1.4 meters apart. So 1.4 meters. This is where distance from something. That's the second point on that triangle we filled in. Find the length of the ladder to the nearest tenth of a meter. We've already labeled the ladder. So we're going to use the Pythagorean theorem or trig ratios. Trig ratios. We are going to use cosine. 1.4 is the adjacent, and the hypotenuse is, our ladder. So cosine from 70 equals the adjacent over the hypotenuse. Do we need to flip it?
Yes.
We do. Flip it, then multiply by 1.4. We're going to round to the nearest tenth of a meter. Do we agree? What did you type in? Did you type in 1.4 times cosine of 70? Times 1 over cosine? It's 1 over cosine of 70? Yeah, he was correct. It's 4.1 meters.
I'm not stressing you.